Welcome to The Explainer. Today, we're exploring the mind of a true American pioneer, Katherine Johnson, the woman whose calculations, and I mean this literally, launched us into space.
Just imagine this for a second. Those were the actual words of astronaut John Glenn right before he strapped himself into a tiny capsule to become the first American to circle the Earth. Now, he wasn't talking about a flight director or some head engineer. Nope, he was talking about Katherine Johnson.
And that one request, man, it tells you everything you need to know about the mathematician whose mind was the absolute bedrock of the space age. It's a story about trusting human genius over brand new machines and about breaking some truly incredible barriers.
So how in the world did she earn that level of trust? Well, it all starts way back in the segregated mountains of White Sulphur Springs, West Virginia, where she was born, Katherine Coleman, in 1918.
From the very beginning, Katherine was just different. She had this deep fascination with numbers. It wasn't just a hobby. She saw the entire world in numerical patterns. She just couldn't help but count everything, driven by this incredible curiosity to figure it all out. Her parents, a farmer and a teacher, knew they had someone special. They made huge sacrifices. Think about this. Because their home county didn't offer high school for black children, they literally uprooted their family and moved 120 miles away, just so she could keep learning.
And her academic career was, well, off the charts. She skipped grade after grade, starting high school when she was only 10 years old. She graduated from college at just 18, summa cum laude, by the way, with degrees in both mathematics and French. Just incredible.
A key mentor, Dr. Claytor, saw her unique potential. Now, he was only the third African-American to ever earn a PhD in math, and he knew what he was looking at. He literally created advanced classes just for her, including one on the analytic geometry of space. And this wasn't just some abstract theory. It was the essential math for plotting a path through 3 dimensions. It was the language of spaceflight itself.
All right, so she has this incredible foundation in math. How does she get from there, from academia, to the absolute front lines of the Cold War and the space race?
Well, in 1953, she gets a job at NACA. That's the agency that came before NASA as a human computer. And what was that? It was a role for mathematicians, mostly women, who literally crunched all the numbers for the engineers by hand. She joined a segregated unit called the West Area Computers, a group of all-black female mathematicians.
And this really shows you the two different worlds at NASA back then. On one side, you had the West Area Computers, a segregated all-female group doing the tedious, repetitive calculations. And on the other, you had the Flight Research Division, an all-male integrated group doing the exciting, cutting-edge analysis for the actual space missions. She was hired for one, but she was destined for the other.
So she gets a temporary assignment with the all-male flight research team, and within just 2 weeks, her deep understanding of analytic geometry and her habit of constantly asking questions made her completely indispensable. Her supervisors, well, they just forgot to send her back to the computing pool. Her talent was simply too valuable to keep segregated.
Okay, so now she's in the room, and from that point on, her work became the literal mathematical blueprint for America's entire journey to the stars.
She calculated the trajectory for the very first American in space, Alan Shepard, back in 1961. We're talking about a suborbital hop, but her numbers were so precise, they told the Navy recovery teams exactly where in the Atlantic Ocean to find his tiny capsule.
And that brings us right back to John Glenn. For his historic flight, the first time an American would actually orbit the Earth, NASA was using a brand new, room-sized IBM computer to plot the path. But Glenn, he was a little skeptical. He famously said, "Get the girl to check the numbers." That girl was Katherine Johnson. And only after she spent a day and a half rerunning all the equations by hand and gave the thumbs up was he ready to fly.
See, this was her specialty. And for the Apollo program, her biggest challenge was calculating the incredibly complex rendezvous between the command module orbiting the moon and the lunar module coming back up from the surface. I mean, can you imagine trying to hit a moving target thousands of miles from Earth with absolutely zero margin for error? Yeah, that was her job.
And then, when disaster struck Apollo 13, it was her foundational work that acted as a lifeline. The crew used her manual backup charts, the one she had calculated years before, and a one-star navigation system she helped develop to find their way home after the main computers failed. Her math, done by hand, brought those astronauts back to Earth.
But her career didn't stop with Apollo, not at all. She kept shaping space exploration for decades,
working on the space shuttle program and even on early plans for missions to Mars.
And her professional legacy wasn't just about the math. No way. She broke down social and institutional barriers with this quiet, unshakable determination. She was the first woman in her division to ever be credited as an author on a research report. She famously just ignored the segregated bathrooms, and she insisted on having a seat at the table in high-level meetings that had always been for men only.
Now, it took decades, but her incredible contributions were eventually recognized with the nation's highest honors, the Presidential Medal of Freedom, the Congressional Gold Medal, and even a NASA research facility named after her. She passed away in 2020 at the amazing age of 101.
You know, Katherine Johnson's story teaches us that so often the biggest barriers we face are right here on the ground, not up in the heavens. And it shows us that one person's courage, combined with incredible precision, can truly change the world. Which really just leaves us with one big thought. What happens when a mind that refuses to be limited is set loose on a problem as limitless as space?